All right, you are being introduced to statistical inference, and we are going to begin with what's called a confidence interval. In the last video about notation, I told you that the sample statistics estimate point, where I said population parameters. The simple statistics are known as point estimates because when you compute a mean or proportion, you just get one value, 1 point. But that still has some error because if you think about it, if you were to collect a sample of whatever interests you, maybe it's income data, and you randomly choose 5 people and ask what's their household income, and you compute the average, and then you randomly ask another 5 people and you get their income and you compute that average, it's likely not to be the same. So that means that the averages or proportions differ from sample to sample. So a point estimate isn't really great. It's a start. And so what might be better is instead of coming back and saying, well, I believe the mean population mean mu or population proportion p are this value. Now what you're going to learn is how can you come back and say, well, I believe that that concept has the value somewhere between this number and this one. And so we're going to figure out how do we get an interval estimate for population parameters. And we're going to focus just on the mean and proportion. The good news is that one sample confidence intervals have the exact same form. They're all made up of a point estimate plus or minus something called the margin of error, which in those top long red boxes are the capital letter E. Now, E is computed differently for each, but just based on the terminology, you could think of it as the same thing. So X bar plus or minus E, the margin of error, gives you an interval for mu, and P hat estimates P, and so P hat plus or minus E gives you an estimate for P. So let's focus on estimating mu. Now, the margin of error, the E value for estimating mu when sigma is known, is given by this box here. So it's Z star or Z asterisk times sigma over root n. But if you don't know sigma, it changes a little bit, and you've got the box towards the bottom. You don't know sigma, so you're going to estimate it with S, but S also changes from sample to sample. And so there's more error. And that increase in error is going to come into play by changing your test statistic, or the critical value, excuse me, from Z star to a T star value. And that's going to bring in a new table. You've seen the standard normal table for Z, but then there's a T table, which is also on Canvas for the T distribution. And so the decision-making process is that simple. It really comes down to, do you know sigma or not? If what you have is S, then you don't know sigma and you're going to do the bottom one. But if you do know sigma, you're going to use it, and you're going to use the top one there, X bar plus or minus Z star times sigma over root n. All right, but what if you are making an inference about P, the population proportion? It's still going to be P hat plus or minus E, but E in this case is going to be given by this term here, Z star times the square root of P hat Q hat over N, where Q hat is 1 minus P hat. So P hat plus Q hat has to be 1. This does have meaning. So if you were interested in estimating the percentage of people that smoke e-cigs, so that percentage would be P hat, which means Q hat is going to be the percentage that do not smoke e-cigs. And so they are complements of one another. And let's see, you're going to need what's called a confidence level, which is 1 minus alpha, in order to find your critical value. And you may have noticed I didn't say it, but at the top here, by critical value, I wrote table lookup. And that's because the Z and T star values are not calculated. They're actually going to be looked up from the corresponding table. So if you need the Z value, you're going to use the standard normal table. If you need the T value, you're going to use the T table. And I'm going to show that in the next video, how to actually find that. So this video is just focusing on the background a little bit and the formulas. So if we wanted to determine, let's say, a 95% confidence interval, that implies that 1 minus alpha is 0.95. Finally, the goal is going to be to create an interval where you could say mu is between these two values, or if you're doing an inference about p, you want to be able to say that p is between these two values. You always put the smaller value on the left, the larger one on the right. And that's it for this video. The next one will focus on how do you find critical values, and then from there we're going to put it all together in order to create complete confidence intervals.